My name's Chris Morrow, and Danny McPherson in the white shirt, and Tim in the greenish brown. And hopefully today we can cover a couple topics, but the main one we're trying to hit is allowing customers to trigger black hole routes in your network if they have some kind of problem they want to not call you about. So basically we'll try and hit black hole routing, some of the tools that you'll need to actually make it work, all free, we like to think. How to allow the customers to trigger a black hole, and then Danny is going to talk about BGP flow spec, which is kind of a way to push out filtering through BGP. So instead of having to go to every edge router you have and apply some crazy filter, you can put this stuff into BGP and hopefully it will work for you there. Okay. So yeah, everyone can read the first question. So how many of you all are responsible for security in ISP or an enterprise network? So, right, look, almost everybody. No, okay, 50%. And how many of you guys use like a black hole routing scenario today? So something, 1, 2, 3, 4, 5. Okay, so good. And have you all ever tried like the source-based black holing that you can use with Unicast RPF? 1, 2, 3, 4, 5. Oh, very easy for everyone. Okay, so yeah, Roland does do that. That's right. And is anybody currently allowing customers to black hole traffic through BGP announcements to you? No? One hand. All right. So aside from Gil, who can't raise his hand for that. Okay, so basically everybody knows kind of what a DOS attack or a distributed denial of service attack is. It's just way more traffic than your customer expected for whatever reason. It could be a legitimate reason like Cisco's latest software update that everyone has to get, or it could be the Victoria's Secret fashion show. These are common examples. Or it could be, I upset some little kid in IRC and a way he wants to get me off the network. So he tries to DOS me off. Very simple concept. So, but that's okay. But the important thing is that it's traffic your customer really doesn't want or that you don't want on your network, and you have to transit it across your network to your customer, so it's going to cost you one way or the other. So the whole concept with really the remote triggered black hole is the ability to go to one place in your network to put in a route that will dump the traffic at the edge. So there's a little bit of preparation you have to do on every edge device, or really every device in your network, just in case something slips through from provisioning or what have you. And you need to be prepared to know how to use the tool and what effect it will have for both you and your customer. Right. And the last point was that this is something, it's not the be-all, end-all of security, but it's certainly a tool that any ISP can use in their toolkit to keep going. All right. Yeah, I would reach it if I didn't dislocate my shoulder. So I wouldn't advise you do that if you're thinking about it. So in my network, and I think Tim uses it for the same reason, and I think Quest also is using black hole routing today for both saving customers and tracing attacks. So we use it today to trace back attacks across our network. It used to take us upwards of 8 or 10 hours sometimes to go hop by hop across the network. We can trace an attack across our backbone, which is of reasonable size, in about 5 minutes. Right. So as long as it takes the BGP route to update and for packets to start coming into our little sinkhole network. What's good about it for us is we have a reasonably sized network, so it takes a long time to go to every edge device and try and find this traffic, or it takes a long time to go hop by hop through the network. And in some cases, you can't go hop by hop because of network design issues that were made to actually get better traffic performance, like MPLS. Thank you. We don't have NetFlow deployed, but other folks do. Tim does, and Quest uses NetFlow in either the Arbor devices or just straight using it to see what's going on. You can do the same kind of thing with IP accounting if you don't have a GSR, which doesn't do IP accounting, at least not in the code we have. Or you can just, sometimes attacks you can tell just because the interface statistics, right? An OC3 that's pushing 200,000 packets per second, probably not what the customer is asking for. So, reasonably simple stuff. Okay, so the whole concept with black hole routing, when it gets right down to it, is you push out a route to all the iBGP neighbors in your network, and you just reset the next hop to something that every router knows is discard or null zero or reject, depending on the router that you have. Or you can actually use the discard interface on a Juniper, which is pretty cool. So early on, Barry kind of had this black hole route concept all along, or his part of it is he was doing it a long time in the past. And according to him, everyone forgot about it and no one was really using it. And for whatever reason, we kind of rediscovered it on our network as a kind of a mistake, which ended up working out pretty well for us. So instead of trying to access list this traffic everywhere, which when you use an access list, your router has to process switch the traffic, or it takes, depending on the platform, of course, it's a performance hit and it's a problem because you have to manage the access list. Routing to null zero allows you basically to route the packet off to non-existence. So instead of having to worry about, am I going to go through this long access list and find out how to discard the packet, you just punt it off to null zero and away it goes. And the router can route faster. In a lot of cases, depending on the platform, again, can route faster than it can access list. Or more conveniently at least. And like the last point says, little to no performance impact. But again, that does depend on the platform. So your 2600 will probably access list and route to null zero at about the same rate. So again, we should also thank Barry and Danny for doing the slides for us. So the basic, as the packet comes in, normally goes into the fib. The fib says, where am I going to put this? And it ships either out the egress interface, or in our case, it could go through a packet filter to discard the traffic, right? Pretty simple. On the normally output, because you're facing a customer. Or if you want to just discard it, it'll immediately route to null zero, so you don't have to bother with the packet filter part. So everybody's favorite example of a customer getting attacked. So all the green lines are the attack traffic, and some poor customer in red is now calling you saying, please save me. The problem with maybe a year and a half or 2 years ago attacks, that's okay. So a year and a half or 2 years ago, attacks were big enough to take out an OC3 or an OC12, but that was kind of about it. No one really could muster enough bandwidth or bots, as Rob likes, to destroy large pieces of your network. But now it's not uncommon to see a gigabit or 2 gigabit bandwidth attack. I have never seen one that's as big as 2 gigabit, but I've definitely seen an honest-to-God million packets per second. So the 10 million, good stuff. Yeah, 1 million was enough to destroy an edge router and make 2 metro routers in our network very unhappy. Yeah, I can imagine. Yeah, the NSA was not happy about that.
The largest DDoS attack for which I have empirical evidence.
Rob,
Hey.
use the mic there. You're recording this, so if anyone has comments, please add them, but use the mic. I should be now. Yeah, Rob, just be quiet, please.
Hi, everybody. I promise not to sing. I'm Rob from Team Kimru. The largest DDoS attack for which I have empirical evidence was 40 gigabits in aggregate. That's 4 OC192s. You could beam a human down that. So, when you talk about DDoS, and Chris is talking about, the reality is bandwidth is not your answer. Bandwidth is not going to save you. And by the way, a lot of your customers think that's the case. And of course, your salespeople don't necessarily mind that. But you need to start pointing them this way in terms of reacting to a pipe that's full. It's not the type of attack, it's just the fact that it's going to overwhelm the pipes.
Yeah, so like I said, about 2 years ago, an OC12's worth of traffic was kind of the best you would see. And now, like Rob's, and back then the answer was, just have the customer buy more bandwidth. Solve that problem right for you right away. But now that's not really a viable answer anymore. And there's a number of competing factors as to why that is, but in the end, bandwidth isn't going to save you. So, and additionally, it's not just your customer that's suffering here. If we flip, so yeah, so if the attack's big enough, which 10 million packets per second, that's big enough to take out a POP. So it's going to take out your POP and some of your transit network to get to the POP, and it's definitely going to cost you money if nothing else, because you're going to have to over provision your internal core circuits to deal with attacks on an ongoing basis. So hopefully we can try and find some way to fix that, right? So. Okay, so if we use the black hole route concept, or the remote triggered black hole, we can have a NOC worker or a security person, like people in the room here, can push out this route into their system. Danny's quick with that button. And hopefully the route goes out to the edge devices and blocks the traffic there, so that the incoming, bad customer, which of course none of them are actually bad, right? The incoming bad customer interface is now getting the traffic dumped. Well, everyone has some that are bad, but ideally it's not them that's actually doing it. So, okay, so yeah, I'm done with that. Thanks. Let's let Tim jump in and.
All right, so remote triggered black hole filtering. So using a BGP triggered network-wide response multi-source attack flow. So So essentially, the setup to trigger, you're gonna Okay. So a static route in BGP will allow an ISP to trigger network-wide destination address as quickly as BGP converges through the network. Provides ISPs a tool. Essentially, so looking at backscatter and traceback, we route arbitrary addresses at least on the AT&T backbone. So whenever we set up our next hop, we set up a couple next hops on the router. So you can pick 3 different addresses, and then you can have different tags trigger on which address you're actually going to black hole to. So, in other words, depending upon the route, you'll see the 192.0.2.1, and that's got a null with a tag of 255 on it. So that might just handle all your edges of the network. Yet you can have another community string. Does that show? Yeah. So then you have a different tag, 199, which might take it so that it's just your peering edge routers that's going to drop the packets. And then you might have a tag 50 that could actually bring it into a different location, so depending upon the tag. So preparing all the routers, you've got your static route on to what routers that you want the triggered black hole to listen to through the BGP advertisements. Once the attack comes in and you've set that route, anything that's coming into the network is immediately going to get put to null 0. Okay, and those are your different hops. So he's got 2.1 here, all BGP routers are dropping to null 0. 2.2, all peering edge routers drop. And these are, once again, based back on the community string that you set. So for each one of these, you're going to have a different community string that's going to tell it what next hop to take. .3, all customer edge routers. Any questions on this? On how the community strings relate to the next hop and how you can set up different edges to respond differently? You know, have your whole network or just a portion of your network. Yeah. The trigger router of this device will inject IBGP announcements. So, yeah, and any tool can do this. You know, if you have a Unix box that's running Zebra, it's not going to matter. Anything that's going to inject the route. So, I mean, it can be you know, we use an old rundown 7500 that, you know, that we use. But I mean, you can set it up with anything that'll do BGP to set that route up. Yeah.
I noticed you had Zebra on there. Do you guys play with Zebra much for this purpose, and how stable is the microphone?
Yeah, so the question was how stable is Zebra for using it for set remote triggers. We use Zebra for other methods of BGP analysis, such as like, I think I was talking to you about Piermont earlier, as far as like looking at BGP routes. So we have enough stability with Zebra in that fashion. We're not using it to set triggers on the black hole simply because we have enough routers out there that we can pull one that's going to do it. But I wouldn't see any stability problems using Zebra to set a trigger. So some other tool integrations that you can do. If you can find a good enough spot in your network to actually redirect into a sinkhole, so you don't have to disperse the attack out on the edge. You can set a particular tag or trigger or community. For example, ours is tag 2020. We'll actually bring it into a specific location into our network so we can actually analyze the attack. So at that point, you can have look at dark address space. You can look for syntax storms, worm detection. We do a lot of things with dark address space. We route a lot of unused Class Cs, a lot of unused Class Bs, as long as some arbitrary address space, and just monitor that portion of what's being sinkholed, and you can get pretty good indications of worm detection if a worm breaks out, or just noise that's happening out on the internet that's occurring. So recommended dedicated trigger device. I really don't think it matters. As long as the device is definitely secure. Obviously, security as far as the rest of your routers go, if you have one device that's going to have the ability to trigger and manage other things in the network and reflect on how your network's going to handle this traffic, you make sure it's secure. So once you have the attack dispersing into your network, then some people lose methods of, they're not going to have a method in order to see the characteristics of the attack. So you need to make sure that you have NetFlow or SNMP, because once you're not singing the network, you don't want to just forget about it. So have a way or method of monitoring the attack once it gets dispersed into your network. This looks like a screenshot from Danny's company, Arbor. This is their traffic product.
Yeah, this came from a European service.
Yeah. So this is traffic. Traffic essentially looks at NetFlow, and you can see some charts up there. So in our case, we use Danny's product, Arbor. And when we disperse the attack, if we do a tag that's going to disperse the attack out onto the backbone, we look at our flow records to make sure that, see if the attack's gone away so that we can remove the trigger, or at least get the characteristics of the attack, see where it's ingressing from. Some more screenshots. Okay, so this is actually how you set up the tag. So you have your router here. You have to redistribute static in the BGP in order to get the static route you're going to set in the BGP. BGP, #66. So there you're setting the next hop, 192.0.2.1. That's going to be in your route map. That's going to put it out to, is that still on? Set local preference 50. So all the routers are going to respond appropriately. Set community, no export. You don't want this, obviously you don't want this exporting out to your other ISPs that are going to be listening. You just want this to occur on your network, and set origin IGP for it. Okay, so then to activate it, all you're simply going to do is set the static route and tag it 666. And you can see from up above, match tag 666, that's going to set the next hop value. And once the router that's listening to that advertisement, it's going to know where to send that packet for its next hop. That next hop is then going to be static routed to null 0. And you can see this is how it's going to travel. So BGP, you're setting the route. The next hop's 192.0.2.1. The static route on the edge router is going to put that to null 0, essentially forming the black hole. There's your trigger getting set. That's the announcements going out. The announcements are then going to null 0, that route, and the attack gets stopped. Community-based trigger. So why community-based triggering? Flexibility allows for more control on DDoS reaction. Like we were saying earlier, Community 1 can be for all routers on the network, Community 2 can be for all peering routers, Community 3 can be for all customers. If you have a customer that's under attack, and it's easy enough to just say, okay, every router in the network we're just gonna put this traffic to null 0. But we have to remember that when you are creating a black hole, you're essentially doing a deny any on that IP address. So you want to have some choices on where you're going to let the traffic through. If you know the attack traffic is strictly coming in through your peering connections, then you can set a tag that your customers are still going to be able to reach your customer that's under attack. Or in our case, on the AT&T backbone, we have a lot of downstream, what we consider downstream service providers. So we want to differentiate peers between downstream service providers and between our customer edge and also our broadband edge. So having those different communities, if we just want to cut off the DSPs from sending this attack traffic or just the peers from sending this attack traffic and still allow some of our larger customers to access the customers under attack is always a good thing. Inter-provider mitigation. This is currently something we're not doing, but essentially how it works is you have ISPA that is now blocking the traffic, and they're sending out an advertisement through multi-hop BGP. Yeah. That is then going to do a remote trigger to other ISPs. So you can grow this larger than just your own network. In Rob's. Yeah.
Hey, Tim.
Yep.
Two flavors of this.
What's your name and where are you from, Barry?
I'm Barry Green from Cisco Systems. Two flavors of this inter-provider mitigation is one with the advent of NSPsec where providers, security professionals from different providers can find each other. People who do remote trigger black hole can then find each other and put an announcement, hey, can you black hole for me? So it allows manual, because you got to go, everybody has to say, so that works. And then we also have tools like the remote trigger, the automatic black hole system that Rob runs, right? So there's another technique. So we have a couple of those things, and Rob's going to come up and talk about maybe a plug for his service.
So Team Kimru runs what we call the DDoS route server project. Some of you are probably familiar with the Bogon route server project. With the DDoS route server project, what we do is we inject a /32 with a particular AS and community so that you can watch it, know about it, or filter it as you wish. So you peer with this. We've got multiples of them now, and we will guarantee you, as much as we can determine, that this /32 is the command and control for a botnet. If you wipe out the command and control, not only are you saving your customers, because now their machines are still infected but can't actually participate in DOS, you may be preventing a DOS from hitting one of your customers. So it's sort of a good netizen thing to do. So if you're interested in that, send us email. We'd be happy to set up a hearing with you. And if you have any questions about our methodology and how we know that /32 is really naughty, I'd be willing to talk to you about that as well.
And like Rob was saying, it's just going to save you time in the long run. I know everything that Rob sends out as far as the botnets go. I always try to have a little bit of fun with them, and I set up my own IRC server and have them attached to me, and see what they're up to. And then I get other complaints from people from CERT saying, "Hey, I attached to this, and you're running like this botnet." I'm like, "No, it's really, I'll attack you if you don't shut up." So. But it does save you a lot of time and effort. Some of these, just looking at our own customers, from some of our broadband, we'll have 400 customers, 500 customers attached to some of these controllers, and it's just going to save you in the long run when somebody comes out and says, "Hey, your network's attacking me." If you nip it in the butt right away, it's definitely less painful. So we got more providers setting up routes to null zero and black holing the traffic. Gotchas with black hole filtering. Routers were designed to forward, not drop traffic. ASIC-based forwarding can drop traffic at line rate. Processor-based forwarding problems, dropping large amount of data, especially architectures requiring exception path punts for drop packets. This is all going to be, your iOS based. I can tell you, 2 years ago we were hampered by a hell of a lot more problems than we're hampered by now. But with anything like this, make sure you check over your hardware, your iOS revisions, and make sure nothing's going to get you in the butt. Yeah, you want to stand up and talk on that, Barry?
His favorite slide. His favorite slide.
Barry agreeing again, since you're using one of my old slides. No, this goes back where it goes to the next slide too. With the AGS had this. Oh, they didn't put that in there. But AGS had this issue where null zero is all process switched. So if you did anything to null zero, your CPU went kaput. Right. So the technique that we used to do was, I don't know how many people remember the AGS. A few people in here, you date yourself. But one of the techniques I know I used to do on all my AGSs, but I didn't work for Cisco, I worked for providers then, is we took AUI connectors and put a T connector on it. And then we would, and this is, of course people call this the drop interface now, right? And that was your drop interfaces. So you would shunt it off to a Ethernet that had a little T connector, right? And if you pump enough packets off the T connector, it may get hot and you can cook something on it. I don't know. But that's the context of this. That it just, in these days of dropping packets, you got to understand your platform and how it drops the packet. I think that's the context of this, even today. CPU-oriented platforms drop differently than ASIC-oriented platforms. And if you understand how each platform drops, then you can use the forwarding to your advantage to drop very effectively.
Okay, so real quick on this, actually I saw one hand on the URPF source-based BGP black holes, and basically what you do is you employ the BGP trigger mechanism and associate a URPF filter with a null entry or discard or reject, depending on what your router vendor is. And you can use that to do source-based BGP black holing as opposed to destination-based. And so that's all that slide was intending to talk about. All right, so customer triggered. Basically, when after you got all the BGP black holing infrastructure and configuration and all the preparation work done, what you can do is after you begin using it for yourself to mitigate attacks and stop deploying ACLs, you can start accepting more specific prefixes from customers to allow them to black hole their own prefixes. So you probably don't want to do that on source-based BGP black. In other words, allow your customers to black hole other sources on your network, because that could be a DOS attack in and of itself. You definitely want to scope their black holing capability to prefixes which they announce to you. I think that's pretty intuitive. I don't know. And then you only want to accept more specifics of prefixes from customers, that they announce. The only problem with that actually is that that unless, depending on how you do your filters, like a lot of service providers, like several service providers accept a prefix from their customer or any more specific of that prefix or any longer mask on that prefix, and so they'll accept a /16 or a /24 within that, implicitly within their BGP policy. On the other hand, a lot of service providers actually have explicit filters that say, I'm only going to accept this /16 from you because it helps keep their customers from announcing more specifics and help save the internet routing table. Not everyone's concerned with that at the moment, but no, I'm kidding. Okay, it's how their policy is defined. But the problem with having explicit prefix filters is that if you've got explicit filters in place and you want to accept more specific prefix from customers, then you got a policy there and it says, I'll accept this /16 from this customer A of mine, and I'll accept any and if you want to accept a black hole community from them, you have to apply a policy that says, I'll accept any of these prefixes more specific to that with this community associated with it, and tag it no export and not announce it off my network and whatnot. So one of the things I've talked to a couple of router vendors about actually is having a mechanism to say, here's an explicit policy filter set, and I accept this or anything longer with this defined community, and tag it with this community, so that you don't have to have one explicit prefix filter set, and you don't have to define another one that says, or these more specifics with this community, so that I won't leak these routes off my network. So does that make sense to you? Think anyone? Okay, good. Someone follow me. All right. Accepting longer prefixes. I think I already talked about this actually. Yeah. So we've already talked about this. This was covered in the last slide. Okay. So more on customer triggered routers. These are the whys basically, and it's mean time to repair, mean time to response. Liability, for example, if a customer black holes something, they were responsible for their network and they black hole their own prefix, so they're the one liable. They can get it, as Chris says, when they want it, where they want it, and it's on their timeline. So there's not a lag and delay that says they send an email to security at isp.com and have to wait for 4 hours or 4 minutes or whatever it is they're going to complain about because the attack's no longer occurring. Tag routes with no export, and so basically, if you accept these routes from your customers, you probably don't want to announce them to other peers, and depending on what policy sets you have in place. So no export's kind of a safe net community. Hopefully most providers have explicit communities to say, I attached this community, and unless this community is there, I'm not announcing this community to peers, because implicit filtering often results in route leaks, right? So, and then the other thing you see in this bullet is no advertise. So depending on how you set up your black hole architecture, they're one of a couple of ways. You could have your trigger device could be a client or an IBGP or UBGP peer of one of your IBGP speaking routers in your network. And then allow that router to announce it to every other router in the network. Alternatively, for faster deployment or security, or maybe you want to have subsets of policy, that trigger device could have an IBGP session with, or a BGP session with every edge device in your network, and so that it immediately sends one update to everyone, and you don't have to rely on the convergent time that it takes to get the update through your network. It depends on how you want to architect your solution. There are a couple of different ways you could do that. So policy announcement. All right, I think it's that. Reporting should be automated. So one of the other things with this is timelines. Like I was talking to Chris and Tim earlier, and they both said they usually have about 300 to 500 active null routed or black hole routes in their network at any given time. Chris said it'd probably be lower if he did a better job at keeping up. But he's got some tools, and he says you definitely want to keep some exception policy in place that says. I'm going to put this null route in for 2 days, and it's either automatically going to be withdrawn or someone's got to acknowledge it. It'll throw another alert up. So you don't want this to be this this dirty wash bin that you throw everything in, and then when someone calls and complains, you take it out again. You definitely want to do exception reporting and monitoring and auditing of it, obviously. So having a random trigger router with some automated process that someone goes in and configures a static route with a network statement and announces something out in your network, that's fine, but if you don't have tools on the back end of that, it could probably turn into a bit of a cesspool, I guess. So, all right. So actually, this is the enhanced policy language thing I was talking about. To me, it's a big deal because I've worked at a couple large service providers, and I know that the explicit filters were important to us, and I don't want to define two sets of policy. So again, accepting more specifics of a defined prefix set if a community is attached, and then tagging it no export or whatever. What other attributes you want to attach. So, All right, so that's that. Before we go on, are there any questions on, that's pretty much it on, BGP black hole routing, customer trigger black holes at the moment. This is basically an extension to that, to BGP flow specification stuff, but does anyone have any questions about this or comments or observations before we go on? Nothing? Okay. All right, fine. So, a few of us, a lot of us have talked about the problem, obviously many people in this room, of either destination-based or just source-based black holing. And one of the biggest problems with it is that you effectively complete a denial of service attack, unfortunately. So someone attacks, Rob's house, and it gets, he's getting slammed, and so everybody black holes it. And well, yeah, he's not getting slammed anymore, but he can't get anywhere anyway. So they've effectively completed the DOS attack, right? And so obviously you want to be as specific as possible. The attackers are getting more intelligent; they're not stupid, and so application level attacks on web servers like some of the SCO stuff, that kind of thing, are a reality. But at the same time, if it's pretty mundane, then you could say filter everything to to UDP port 53 on this device, and be more specific about mitigating an attack as opposed to taking a host or a set of hosts offline. And so that was one of the drivers for this draft. Actually, is that that if you want to, you have like a discontiguous set of IP addresses or a set of port ranges, or depending on how you want to, how you've architected. If you want to do source and destination based, it's a fixed set of prefixes and still employ BGP black holing, then you can't do that with BGP. You got to push filters out in your network and maintain filters and augment filters and hope the line cards you have support that hardware filtering capability, all those sorts of things. And so basically, we wrote a draft. I did this with a couple of other folks, and actually so it specifies some procedures for defining a flow specification within BGP, and we'll talk about the philosophical issues with this before we finish. And then it basically allows you. We define two new address or a new address family and sub address family in BGP, and basically allows you to encode like protocol types, port numbers, ranges of addresses, whatnot, in a BGP update. So from a trigger router, I could black hole a set of source addresses to a set of destination addresses on a given port, given protocol from a central point in my network. And so long as the forwarding logic and my router vendors implemented that, I wouldn't have to augment 1,500 router filters in my network, and I wouldn't have to go push it out and change 15 things. You could do this from a central point in your network. So this is what we're looking to progress in the IETF. So okay, so flow specification, it's an end tuple. This is basically just talking about what you could do with that. Then once it's defined, it's very much like BGP black hole routing. You could say, attach a green community, which means on all ingress interfaces, I want to drop this address family, sub address family, this defined filter, I want it applied to these interfaces. And then you could have that pre-configured in your network. So you could have peer interfaces and customer interfaces and all interfaces or core interfaces or sinkhole interfaces or whatever it is you want. And so you can define those sets, and then you could trigger that with a single BGP update, into your network. So, all right. So it's for DDoS mitigation, and then it's kind of a natural evolution from that sense, I guess. The problem is the natural evolution for DOS attacks are application layer, and they're taking production services off, and so it's kind of arguable from that front. But traditionally there was destination-based black hole routing, then URPF source-based stuff, and now this would allow you to encode explicitly anything basically in a packet header match that you'd want to filter on, or forward to sinkhole, it could be the same mechanism. That's one of the distinctions we didn't make, but everything you do with BGP black hole routing, it's a function of setting the next hop, and if you wanted to set your next hop to a sinkhole device or some kind of analysis workstation, that sort of thing, it's simply a matter of putting a different address there and having the device capable of parsing the data. And so the last NANOG, the NANOG before, Barry Green and I actually talked about sinkhole routing, and all the mechanisms are exactly the same as this. You just set the addresses to a different set. So, okay, and then the flow spec stuff, obviously it's much more precise. So ranges, you don't need 500 routes for 500 discontiguous. You could put a range of addresses in there, sources, destinations, ports, etc. Okay, and then how many folks in here have actually read the draft, the BGP flow specification draft? How many? So I saw 2 hands. Of those 2, do either of you care about this? Taking a poll here. Okay, so good. 50% of the people in the room that were familiar with it. Okay, great. So no. So basically, we haven't.
Andy, here's Barry.
Go ahead, Barry.
And I care so much, I'll probably we'll start hacking on, editing on it to keep it going. Because think about this, where we're going with this. One, you know, the whole idea of this whole black hole bit is we are providers who control big backbones, and we control how packets flow. And all we're doing is controlling the bad packets and having them flow in a certain direction. And so remote trigger black hole is very good for layer 3 destination. Well, that's very coarse. And then unicast RPF loose check gave us source and destination. So now we have two tools. We can drop based off source, we can drop based off destination. But as you've seen with different attack patterns out there, we actually need to have that sort of speed. You know, the speed that you can get like something like in Tim's or a Chris's network, and have something happen like, you know, in 60 seconds you're having a black hole triggered all across their huge backbones. You're going to need that at layer 4. You need to get into, you know, the packet size. You need to get into the port numbers to respond to some of these incidents and these worms out there. And that's what the flow spec is taking us down the path of giving another tool that we can go down and do that. So why should you care about this? This is why you should care about this, because something like this you don't want to happen just with one vendor. This needs to be on all the different equipment out there, because you want to have the choice and the option of picking the best equipment for your network, whatever that vendor may be. And you want something like this to be able to work on it. So this is why you should care about this and participate in this effort and say your 2 cents about it and read about it and keep track of it. And then when it gets to a point where you can turn around to your vendors that are in your network and say, are you going to do this, right? Because you guys control the purchase orders, and then you can say, are you going to do this? So that's why you should care about this effort.
Okay, any other comments on that front? So yeah, we plan to continue progressing this either within the GROW working group or the IDR working group within the IETF, and it's actually pretty bad right now at specifying a flexible filter specification language or flow specification language, and so we plan to extend that. But I got a link to it on the next page. The other thing is, I don't know if any how close many of you in the room are to BGP, but there's this whole argument in the IETF, or discussing the IETF right now, of routing protocol overload. And and some people even argue that using BGP black hole routing alone is overloading BGP, and you're doing things with with a control plane that's exploiting things that could affect the network inversely, as opposed to how they wanted to do that. And so I'm actually a member of Dave Meyer. I don't know if he's around. I saw him a moment ago, but and I and a few other folks. There was a design team in the IETF that was to address this issue of are we overloading routing protocols? Are we we've got layer 3 VPNs, 2547 kind of stuff, layer 2 VP, VPLS, VPWS. There's all kinds of stuff in BGP, and so does something like this belong in BGP? It's a valid question, and if it doesn't belong in BGP, where does it belong? Is it a new protocol, and are you actually willing to deploy a new protocol in your network, that sort of thing? So that's an argument and a discussion that's taking place, and if you got feedback on that as well, we're certainly open to listen. Yeah, John, go ahead.
Danny, John Christoph at Northwestern University. I would say it probably doesn't belong ideally in BGP, although it's a pretty interesting idea, and I'd like to see it tried just in practice. Steve Gill and I talked about this a while back as well. I like the idea of maybe pushback as a separate mechanism to do it for a couple reasons. One, because it makes BGP a little bit easier to change if you ever need to do that without having to carry this baggage with it. But if you did try it, maybe at least a separate BGP session to do this specifically,
Sure,
as opposed to coupling it with your existing routing stuff.
Right. No, that's certainly valid, and that's actually something that's viable with address families. As anyone here that's configured a router recently sees 10 different address family, sub-address family, configuration contexts. Then separate BGP sessions, and actually some folks do that today for for like IPv, VPN and LRI with BGP, that sort of thing as well. So yeah, that's a good comment. Any other feedback on this at the moment? The link is actually here, and you saw there, it's got the author names, and so actually the link isn't there, is it? Did I put it on here? There it is. So that's the link to the draft. The current draft's expired off the IETF website. They expire after 6 months, and no one's had time to do the work, and so that's the name. I'm Danny at tcb.net if you want to have questions or comments or whatever. But that was it for the BGP flow spec stuff, and then. I'd like to thank Barry. A lot of these slides came from Barry. Barry and I and several other folks contribute to something called the Security Boot Camp, and we there are about 2,000 slides there now, I guess. And it's how to do everything from management to control the data path preparation and, and whatnot for your network. And actually all the content for that is available here. So if you're looking for, for some good things to start looking at your network from, from packet filtering to whatever, there's a link there, and it's got about, well over 2,000 slides. There's a bunch of different decks that you could have a look at to how to prepare your network precisely to do these sorts of things and some of the caveats and whatnot. And then also Brian, who works with Chris. I think he still works there, worked with Chris. So he was an early contributor to a lot of the BGP black hole routing and some of the backscatter stuff as well. So, where's he at now?
I think in a couple weeks he starts at Montgomery County Public Schools.
So he got out of the big carrier world, I take it. So he's moved on to new things. So yeah, Brian was the other guy, but Barry did a lot of work on these slides, and I did some, and then obviously Tim and Chris both reviewed and gave us lots of feedback. So that was pretty much it. I don't know if folks in here have questions or comments, or if something's not clear you want to talk about. You're probably not the only one. So if you got something you want to bring up at the mic, feel free to come on up. No one? Everybody's going back to South Beach. They got to hurry up and get. No, okay. Go ahead, Wayne.
Hey, Wayne, Verizon Internet Services. I was just wondering if anybody had any comments or feedback. You mentioned up there about the mechanisms to monitor the routes that you're black holing. Like once you put the static route in, you're going to black hole them. You mentioned tracking 500 some odd routes. Perl scripts. Web fronted to something homegrown. What are people using to monitor and track those black holes and when they take them out?
There's two types of monitoring that we use in our network and inside the UUNet, or the MCI Internet Backbone. So we have some homegrown stuff that NetEng has to just watch growth and change in the route table, both in the IGP and in BGP. So they do some tracking of it there. For our stuff, really, it's more abuse-based or security-based, and it's kind of our responsibility to take care of it. So we have a ticket system that manages all the abuse information, and ideally myself or James Gill, who's here, or one of the other 3 people that do that, are supposed to go through and check their tickets and make sure that it's appropriate to still be black holed. What that means is you take the black hole off, and if the customer calls you, then you have to put it back on. But I think, Tim, you said you use your Arbor product to watch NetFlow?
Yeah, so we generally use NetFlow at the ingress when where it's getting dropped. We also look at our IGP going to the address that's getting set at the next hop. As far as like removing black hole routes, though, it really relies on our ticketing system. We get a ticket, we put it 7 days out, we notify customer care, and after we notify customer care, 2 days later it gets removed unless we're told otherwise. And so, we don't want to end up with just a place that's going to have thousands upon thousands of /32s routed onto the router. So we've made it very clear that we're going to set up a procedure to remove these things regardless of what response we get from the customer care agency or even the customer. So 7 days out, we contact customer care telling them we're going to remove it. 2 days later, and it gets removed unless we're told to keep it. And then we repeat the process 7 days out, 2 days, and we'll remove it.
Okay, Barry Green. This is for Tim and Chris. Since you're allowing customers to say, give me a community, and with this community you can adjust routing on my network, which is kind of like the paradigm of RC.
We trust our customers to route things appropriately. So some of our requirements is, one, obviously in order to send communities, you're doing RFC 1998. All of our customers are route filtered. We've gone through our provisioning system to ensure that they're route filtered. Check it once, check it twice, check it a third time. It's our biggest fear is that a route filter, a route map will get removed from the customer and they will have a free edit. So we have ensured that check control mechanisms are in place in order to do that.
Yeah, we have a very similar setup, I'm sure, as that Tim has and a bunch of other larger ISPs have. It's a process in place to check to make sure every customer that's BGP enabled has prefix filters or distribution lists depending on the platform. When they send us the community, there was initially some fear about the customer being able to affect routing on our network, but I think what wins out is you let them, aside from the standard RC 1996 or 98 filtering where they can, or route map where they can, change local pref or, add AS prepends and whatnot to their routes. If you let them just do the black holing, all you're letting them do is throw their own traffic away. So as a funny case, Sprint Canada decided that they wanted to start using the black holing, and they accidentally set it on all of their routes. So they sent us like 500 routes or whatever, and every single one of them is tagged with the black hole community. And they call in with, we're not getting any traffic. Well, you actually asked them not to get the traffic, right? So, customers can shoot themselves in the foot, which is definitely a problem, but yeah. In the end, this helps out us. It helps out me and Gil because he doesn't get woken up. But it helps the customer out because, as we pointed out, it's on his time or her time. It's what they want, more or less, and they can check it whenever they need to. They don't have to call in and wake Gil up at 4 in the morning, and he comes bleary-eyed to the computer and maybe mistypes his password a couple times, and 20 minutes later, yes, you're still under attack. So
do you see the need of the existing filters that are in place for security, BGP enforcement, and RFC 1998++ DC, the need for doing community on top of that? Like only allow 701:**.
I think today, if I remember correctly, I'd have to check the route map set up for customers, but they can only send us 701 community anyway. So it's, or 701, 702, 703, or 1450, 40, whatever the Latin American AS is. It's teeny tiny today. So it's the same route map for all customers on all parts of the network. So they can do the black holing today, although we request that you give us a call and set it up because there is some setup on our side that has to happen still. They can send us any of the 1998 plus local pref changes, metric changes, and AS prepends. They can do all that by default. If they send us another community, it doesn't really do anything, and I think it actually, I don't think it gets stripped, but it's kind of pointless to have it. So if they figured out some of the other communities, they could do things like not send this route to peers, but what's the point of that for them?
Right. And then do you have a document for your customers for all this to show them how to do all it?
I believe that NetEng put together a document that lists the current set of communities that we have, and I think it was available on, at the time, the WCC, the WorldCom Customer Center, or whatever it's called. Now it's the MCC, but whatever, different name every month. So it's it's kind of comical. That was available one time. I have not personally go to try to find it because I don't need to, but I could go look, certainly.
At least with our network, all of our customers have the same customer-facing route map. For customers wanting to do customer-initiated black holing, it's on a case-by-case basis where a new customer route map gets put in place. Going back to giving customers the ability to do this can save your network as well, as far as collateral damage occurring. Some of our bigger customers, they can take an attack. They have some bandwidth, and they can definitely take a significant attack. An attack big enough that it can affect our head ends, our edge network. Not too worried about the core, but it can cause collateral damage. And giving them the ability to do that can at least remove that collateral damage off of our network. That might be impeding another customer.
Tony Roll, IBM. I missed the first couple of minutes. You may have covered it, but more likely you may have said, we don't want to cover it today. But, what I'm getting at is, here in the typical case, you have DOSed, your customer, and now what's going to make it go away? Not what's going to make the routes go away. What's going to make the attack go away? And is this just something you haven't chosen to talk about today?
We can, at least I'm willing to talk about it really quickly, at least, to try and cover it. So first off, in my network, the things that get attacked more often than not, so well over 90%, are your mama wears combat boots to bed.com, right? And the person who owns that IP really doesn't care about that IP. Right. More often than not, they just want the attack to stop, so their T1 with their 5 shell servers will continue to work again. Right. It's not very often, like a very large site like eBay or Amazon or something like that is getting attacked, and they call. Well, eBay is not a customer of ours anymore, I don't think. But the point being, larger sites or really important stuff on the network doesn't get attacked as often as unimportant piddly crap that can go away and no one cares about. So first off, that, scope the problem that way. Do you really care about the host or not? Some people don't, some people do. So, and Rob's going to give me some statistics in a minute and tell me I'm wrong. But, but anyway, so for those sites that do matter, right? If Cisco is a customer of ours, or a customer of AT&T's, I think, and a couple of other people. Whenever Cisco's site gets attacked, Roland calls up, and Roland, the IT guy, calls up and says, hey, I need to get this fixed. I'm going to send you this community of black hole traffic, but it's my www.cisco.com, and we really can't have that down, right? And that's understandable. So you work as quickly as you can to find the ingress point for the attack and block it if you can, right? If the equipment allows you to block it.
And just also something to get the bad network, to get it off, to prevent the collateral damage. It's a lot easier to black hole the traffic and put it into, you can put it into a sniffer or something like that and look and examine the statistics of the traffic and then go back and place a filter on it. So it is a good method for just analyzing what the bad traffic is and then going back and placing some other form of mitigation.
Yeah, but your question really is like, so I black hole this and it's in black hole for 6 months and I take off the black hole and it's still getting attacked. What am I, the ISP, supposed to do about this, right? More or less.
Yeah,
in kind of a harsh way.
ISP, but what is anyone going to do about it?
Right.
I think we can all imagine kind of a worst-case scenario where it's a really broad-based DDoS of really important targets.
Right.
It's not going away by itself.
Right. It's important targets. It's multi-protocol, and it's from 100,000 sources. Right.
It's like 99% of them out there are, your mama wears combat boots, and 7 days later the attack's not going to be there any longer. But there is those ones that are persistent that it's going to last for as long as they can sustain the attack, and that's just a matter of at some point in time you have to collectively start tracing it back and contacting other providers. NSPSec is really good about that. If I do get one that's persistent, I can shoot something out to that group, and we can eventually track it down and stop it.
Yeah. Nothing formal though.
Yeah,
It's
nothing
very
formal.
informal.
Terrible to be short. So when you look at DDoS attacks, one of the things that you're probably not doing while you're being hit, and this goes to Tony's question, is why? Why was this customer hit? Big or small, it really doesn't matter, right? Why was this customer hit? There's a reason. It's not random. There's a mission, and in some cases it's for pay, and in a couple of cases it was several $1,000s US per DOS attack. And once that mission's accomplished, the attack will stop. Because that person met the SLA. You've heard these terms? They use these terms. They have contracts. So once the mission's accomplished, move on. Because the reality is, if you build up a very large botnet and you're going to do DDoS for hire, you don't want to lose that botnet. If you fire that botnet up against eBay and do a fire and forget for 3 weeks, you're going to lose that botnet. Now, here's the good news. For those of you who build botnets, they're easy to build. That aside, if you're in it for profit, then you have expense and you have revenue, and you're going to measure these. And guess what, folks? They're in it for profit. This isn't for fun. So even in the case of your mama wears combat boots, there's a profit motive. It may not be cash, right?
I just have to add in on the botnets. It is fun to watch them compete over their botnets, too. You'll notice if you hijack a botnet server or something like that, it almost immediately gets attacked, or somebody else is trying to gather up the bots from.
Oh yeah, botnet theft. It's called jacking, botnet jacking in the underground. And these guys are stealing from each other all the time. So, by the way, most of the DDoS you see is bad guys DDoSing other bad guys. Or you think your botnet's bad? Bring it. Right? You remember the attacks on the anti-spammers? Right? Those were pretty significant, right? Before that, the spammers had reached out to these people who run big botnets and said, we want to hire you to take out this anti-spammer. I'll pay you this much money. And they do it. Well, then the guy running the botnet caught a clue. Wait a minute. My botnet will also send spam. I don't need this guy. And what's worse is I know he doesn't have a botnet. Yeah. And so you would DOS me, then go to the sponsor back there and say, I've got better SLAs. Now he's doing DOS and spam for hire. What you hear a lot in the press, and certainly from the security community, which is my favorite comedic enterprise, is that the next worm that comes out will kill the internet. All of them will kill the internet. How many have killed the internet? Yeah, wait. I've not slept, so clearly the internet is still up. That would be fun. So the point here is, why aren't they going after the internet? Because, folks, that's how they make their money. The internet is not the target. The internet is the delivery mechanism. Change your mindset. You change your mindset, all of a sudden all this stuff that never happened and all this stuff that does happen makes sense. So to your point, are we ever going to have something that's big and bad, multi-protocol? Yeah, probably. Is that going to be your everyday? Is that what's pushing these people to do these bad things? No. You're in this business for profit, so are they. You'd be surprised. If you don't have a botnet and you want somebody to go down, you'll pay.
Profit, political. I mean, that's. I mean, it could have been politically motivated with SCO, which translates into money.
Yeah.
I mean, what's interesting about that, about the entrepreneurial spirit now in the miscreant community, the miscreant economy, right? As I'm using Rob's term, the miscreant economy. It was really interesting. A couple of days ago, one of my colleagues called and said, "Hey, this is pretty cool. All my cable customers are getting cleaned up, and I'm not doing anything because there was a miscreant going through with this latest SCO, Trojan, and going in back doors, breaking into it, patching it, installing their own new Trojan." So the SCO problem was going away on this cable provider because this guy was going through, this is good. I could take all these and build my own botnet. So they're going through and rip and throw them and creating their own botnet. Opportunity, right? Entrepreneurial opportunity. And you get this weird reaction where they're going through and patching it because they don't want anybody else to take over it, right? It's their new weapon. And what are they going to use it for? So the question is now I got all these computers that are patched from the old thing. They got a new thing in there. What are they going to be used for?
Okay, so any other comments? Anyone got any questions or anything? I guess this should end with, the NSP security BOF is tomorrow afternoon. And so I would guess that most of the people in this room would probably want to attend that. If you haven't already, you certainly, want to at least know about it if you're involved in network security. So,
Give a quick plug for that since I didn't pump out to NANOG what the agenda items are. Two key things. You got Jim, raise your hand. He's one of our the guys involved with the government side and the government hopefully not doing things that's going to impact all of us in this room. So he's going to give a couple of multiple governments. Right. And how to give an update on that. He's about a year ago he came in and gave an update on that. And then we're going to go through and I'm hitting on several people in this room to talk about when we put out these reports of saying, okay, hey, here's a whole bunch of infected computers that are open proxies. And we're sending out these reports now to people, because this goes down to thing, what are people doing about it? We're going to try to find out what people do about it. And I'm hitting out different people. Even if only thing you do is get up and say, well, I send it over to my abuse people, and the abuse people don't do anything. Even if it's just that, we're trying to get a sense of what are people actually doing with the reports and doing things with it. So that's going to be kind of like the agenda item. And then open mic, anything else anybody wants to bring up. If you have something particularly you want to talk about, find me in the hall. We can put it there, and this is your BOF. Yeah. It's open. It's open to anybody. It's a BOF, right?
okay, with that, I had the beach pictures up there. I was figuring that. No, so I guess we're done if no one else has questions. So it's $12 that way. So yeah, we're done. So with that, I guess we're done. See you tomorrow.